I'm Dan Holohan at AHR, and we're visiting the REHAU booth, and Ryan Westlund. Hi, Ryan.
Good to see you, Dan.
It's great to see you. You know, you guys make world-class product, and I wanted to talk about radiant cooling.
Sure.
Because there's a lot of misconceptions that I pick up on, particularly on our website, where people come in, they think it's black magic, or they're concerned about, I'm going to walk in, slide all over the floor, and I know that's not true, but how do you address that with people that don't want to believe you?
The fear of a slip and slide is a little overblown. To be honest with you, if you're controlling the system correctly, you're running your system above dew point, you will have a safe and reliable heating and cooling system. The thought that we're going to create these indoor slip and slides where everyone's sliding around on the floor is really unfounded. The way we're dehumidifying buildings, the way we're decoupling our systems and allowing our air systems and our hydronic systems to run in tandem really takes away that whole fear.
So you're really focusing on the dew point.
The idea is keep a little bit above the dew point, and what we like to do at REHAU when we design projects is stay at the manifold, the entering water temperature at the manifold, 3 degrees above the dew point. That way, nowhere in your system, everywhere else it's going to be slightly warmer, obviously, as the pipe is going underneath the slab. So everywhere it's going to be a little bit above that. So if we can avoid condensation on the manifold itself, we can avoid it throughout the entire system.
Now I know you just opened up a new building in Alabama, a big building, and it has radiant cooling in it.
Sure.
And Alabama's got to be the stickiest place in the world.
And that's the misconception, that you think that you have to build it in an arid, dry climate. It's not true. If you have a reasonably tight building and you're implementing these things in your controls that are monitoring your dew point and adjusting flows based off of that, so we're either going to raise the entering water temperature or increase the airflow to space to pick up that latent load, because radiant is the real sensible side of it. So it's carrying all that non-humidity side of heating and cooling with it. So as long as you keep an eye on that, we really don't have any issues. And it's a very straightforward design, and the idea is get as much pipe as you can under the floor and keep the temperature as constant as you can keep it. And it really doesn't need to be voodoo science. It can be fairly simple.
And we're depending on the body to just give up heat to something that's cooler, and it's kind of that sensation you get in the supermarket.
Exactly.
When you're in the frozen food aisle. And
exactly.
The air temperature is 70, but you're feeling cold because your body is...
And most people think when they walk down that aisle that it's actually a lower temperature in that. And oftentimes it's exactly the same as the next aisle over. But you're able to get this sensation of your body giving off heat to those cooler surfaces. So not to get too technical, but if two surfaces are different, they will always try to equalize by emitting radiant energy between them. So that's why we have radiant heating and cooling, right?
You know what I like too is that you don't have that cold air blowing on you like you have in so many of our American office buildings and apartment buildings,
Sure.
Where you just got this cold blast coming on, and then it's gone, and it's back, and it's gone.
And the idea is really decoupling the two systems. So our ventilation air and everything from ASHRAE 62 that requires us to have more fresh air in our spaces doesn't have to be associated with the cooling side of it, right? We can actually play with this and be more energy efficient by actually separating them. So when I need air, I use my air system. When I need cooling, I can use my hydronic system that's more efficient. And so by balancing that out, we're seeing 30 to 40% savings on radiant heating and cooling projects around the world, regardless of if you're in a humid climate, regardless of if you're in the middle of the jungle, down in Alabama in our training center down there. So it can be done, and it's not crazy. We went from being an emitter to being now a sponge of grabbing those BTUs and kind of pulling them in, versus in a heating mode, we are the source. We are radiating heat out, which most people can wrap their head around.
Yeah, that's a great analogy, an emitter, a sponge.
Yeah, it's a BTU sponge. That's what we're literally grabbing heat energy from the occupants, from the surfaces, from the lights, from all these little emitters we have, our computers. We don't even think that we have all these little sources of heat in our building.
Future looks bright.
Hey, that's why I talk about it. I'm a passionate guy about it. I think it really is something that people should take notice of.
You got me all excited.
There we go.
Thanks, Ryan.
Thank you very much, sir.